Okay, I just wanted to welcome everybody back from our short little break that we had. This is the R4DS book club. We are going to be discussing chapter 16, factors, today. Like I mentioned to the group at the start, this is a pretty straightforward chapter. Factors are pretty straightforward. The operations to work with factors are pretty straightforward, so I don't think this is necessarily going to take a lot of time. But there are a couple things that are really important to kind of discuss when actually using factors. So some of the learning objectives that we have today, first, we have to discuss what are factors, and then we have to discuss how do we create them. And so we're going to talk about two different ways to create factors, both using base R and what the book suggests using the 4cats package. In addition to that, we're going to take some time to explore the general social survey data set, this object called 4cats GSS cat. So this is a data set that's embedded within the 4cats package. We're going to talk a little bit about that. The reason why we're going to use survey data today is because in survey data, there's a lot of categorical data, and naturally categorical data are great to be converted into factors. And so that's a great example to show what factors are, how to use them, and how to use some of these 4cat functions to work with factors. We're also going to talk about the two kind of general operations that we usually will use, or that we'll usually do on factor variables. So we'll talk about how do we reorder factor levels, and we'll also talk about modifying factor levels. I don't think it's worth our time to highlight every single one of these here in the overview, but we will be talking about each one of these, and we'll share some examples about how they work. I think for me, the stuff that I learned a lot was down here in the modify factor levels, which I'll highlight some of the key takeaways, which I thought, oh, yeah, these are awesome functions to consider. So let's start off with an introduction. So factors, and I made mention of this at the start. Factors are categorical variables, right? So going back to your statistics 101 courses, if you've had the opportunity to take one, there's different types of variables. The one I was taught was nominal, ordinal, interval, and ratio. And so with factors, factors are great for nominal and ordinal, which can also be categorized as categorical variables as well. Like it's been a while since my statistics 101 course, but that's basically what I remember from it. So, but that's where factors come into play. And basically, categorical variables are just variables that have a fixed and known set of possible values. So the examples for today, what we're going to do is we're going to talk about months, right? Months, there's only 12 months in a year. We have January all the way to December, and we have other months within there. And so there's only a fixed set of known values. Another example in categorical variable would be something like a Likert type scale. So if you're somebody who works with survey data, things like strongly agree, excuse me, I can't think of all the scale items, but strongly disagree or disagree, strongly disagree. That could be also considered a categorical variable as well. And so that's where factors come into play, is giving us the ability to have a little bit more functionality and ways to kind of maintain data integrity with those variables. And then also some other operations that we can use for them. So what we're going to do is we're going to use a core tidyverse package called 4cats. It is a play on categorical variables, which I think this is one of the best named packages out there. But if you're not familiar, what we're going to be using is the 4cats package. I highly suggest taking an opportunity to kind of look through the package documentation, especially if you work with categorical variables in your types of analyses, because 4cats has a lot of different functions and convenience functions that can help you with a lot of different operations that you potentially could come across. In addition, I encourage you to look at the cheat sheet. I think everybody here is pretty much familiar with the cheat sheet for the tidyverse, that most packages have that cheat sheet. This is a great summary of all the different operations that you can do with a factor. So jump back here. Yeah, and then so also factors are great for if you want to display character vectors in a non-alphabetical order. So if also use so when you try and sort things, or when you're trying to sort certain sets of objects, especially with a character vector, it will tend to sort alphabetically. The book did say something about some computers don't do that. I would like to know a little bit more about that if somebody knows a little bit more, but we can get to that in a second. But factors are great just in case you need a very specific type of ordering outside of alphabetical ordering. Okay, let's talk about factor basics. So factor 101. So the motivating example for today to talk about what factors are and how to actually create them, we're going to use months. There's 12 months in a year. And what we could normally do with the tools that we already have and that we've already learned, we can create a character vector with some strings, right? And so we can use the C function. We could go December, April, January, March. However, when we do that, there's some issues. Well, the first issue is that, well, we know that there are 12 months in the year, but we're only capturing 4 months within this vector that we're creating here. So we have no way to adjust or catch any way to make sure that we are spelling the months correctly. So if you look very closely here, for January, we accidentally had a typo of Jan. Because we're using a character vector, there is no way outside of us just manually checking it that we've spelled everything correctly. Using a factor, what we can do is we can set specific levels to make sure that any variables that get stored within a factor variable follow those specific levels, or they default to NA. And so it gives us a little bit more help for data integrity purposes. In addition to that, when we start using like forecast packages to create factors, if specific levels in our specific strings in our character vector are not of what is expected, it will push an error. So that's really nice as well. The other limitation is when we try and sort this, which I mentioned before, it's going to default to alphabetically, right? So we would necessarily think when we were trying to order months, we would go how it is in the calendar, January, February, March, April, May, so on and so forth. But because we're working with the computer and we sort it this way, it's going to go A, B, C, D, E, F, G alphabetically. Now, the book did say something, and I'm going to ask the question here, but I think I remember reading something in the book where it said like, not all computers are going to sort alphabetically, but I didn't necessarily understand that, or if that was something that just wasn't clarified, or if that's just something that I didn't need to like think too much about. But I don't know if anybody's ever come across that case where you tried to sort something and it didn't do it alphabetically first. But I don't know. Does anybody have any examples of what the book was talking about? Yeah, that didn't make much sense to me. Yeah, so I'm just not going to focus on it too much. But I read that there was like a line in there that said something about that, and I was like, oh, well, okay. Okay, so how do we fix these issues? Well, what we could do is we could use a factor. So the first thing when we create a factor, what we need to do is we need to specify what are the levels of that factor. And in our case, because we're using months, we have to specify what are the 12 months in the year. And again, we're using an abbreviation for the months in our case here. And so what we do is we have to create a character vector of strings with all the different levels that could potentially be stored within our factor. So here we have what's called month levels. And basically it's just a character with a bunch of strings that represent the months. To create this factor, we have the first set of tool, or this first function available to us is from base R. It is this function called factor. What we do here is we take our character vector x1, which isn't really made real clear here, but previously it's just those 4 months that we had. And we pass that into the factor function along with our levels. Again, when we look at this and what gets actually outputted, and we're just going to sort it here real quick, we have what we are storing within that vector or within that factor. So January, March, April, and December. But what's get modified is now we have this, I think it's an attribute that gets attached to this, and someone correct me if I'm wrong, but we get this attribute that's connected to this factor that has these different levels. And so basically this is like extra metadata that is available to specify these are the only values that should be stored within the factor. We have this, this is what we have actually stored, but we have this extra metadata stored as an attribute attached to the factor that says, hey, these are the sets, or this is the set of values that we will only accept within this. Like I said, somebody correct me if I'm wrong. If it's an attribute, I think it is. But yeah, that's basically what I wanted to get out of that. There's one other thing too that's interesting about factors, and this is goes a little bit beyond what's discussed in the book. But if I remember correctly, and I think this comes from like advanced R, these levels are not stored as like we visually see them when they get printed, the actual like values, but they get stored as integers in the back end. So like these would actually get an integer value. And so factors, one benefit which doesn't get talked about in here, is factors are faster to sort because strings are such as a little bit more data, more information. But if you store it as an integer with that like metadata, it will sort faster. I don't know if people are working with data sets that have a significant amount of data, especially significant amount of factors that they're storing. But that integer storage helps you sort and actually helps you process factors a little bit faster. Any beginners who's maybe watching this later on in the future, if that is something that goes over your head, don't worry about it. It doesn't come up. It's just one of those little tidbits that is kind of interesting to dig in when you kind of look at what are this like factor data type. Okay. If you omit the levels, it will just store the factor levels alphabetically. So what's really important here when we do this with factor, when we set the levels, it's going to set the levels based on how it shows up. So if you use this base R function factor, pass in month levels into the level argument, it will create the levels and it will order it based on how it shows up within the way you specify it. However, if you don't specify that, then it's going to just sort it alphabetically. In our case, because of what we're working with, not what we want. So, okay, so big warning. When you use factor, if you use the base R factor and you set your levels using month levels, and you pass in a character vector of strings, and it contains a value, specifically our misspelled one, JAM, it will still create the factor, but any strings that do not match the set of values within the levels will get turned as an NA. That's dangerous in some cases. So what the book suggests we do is we switch over to using FCT from forcats to create a factor. I myself need to go back through my work because I have a lot of code that uses factor and levels. So that's something that I'm going to take away from the book is probably go and convert a good chunk of my code over to forcats FCT. Again, I guess that's based on your use case. I mean, if you want to use base R, that's good. But FCT from forcats just gives you a little bit more kind of checks for data integrity, because if it's missing something or something's spelled wrong, it's going to push an error. And it's also nice because this error will tell you what is the issue, jam. In our case, because we only have like 4 values within this character vector, it's not really that big a deal. We can find it really easily. But if we had 1,000, 2,000, 5,000 different, things within our character vector, that's kind of nice to know what's the issue. And so FCT provides that kind of convenience. If you ever need to check your levels of a factor, you could just run levels. There's a function called levels, and then it will output what the levels are. Again, just getting that like levels attribute that's attached to the factor, and then it prints it to the console. Okay. So I'll take a second before we talk about other ways dealing with factors, but does anybody have any questions? I know this is a pretty straightforward discussion about what factors are and how to create them, but I want to make sure to give some space if anybody has any questions. Yes, I love that, Stefan. Forcats is also an anagram for factors. I think that I have to give some mad props to the Tidyverse team because they are really good at like branding their packages and making some really good package names. And Forcats is one of my favorites. Lubridate is also a really good one. Per is also a really good one. So yeah, shout out to the Tidyverse team for having some. I don't know if they have like a person that's just specifically focused on like branding, but yeah, mad props to whoever's setting that stuff up. But all right, cool. All right, there's no other questions or comments. Let's talk about other ways of dealing with factors. So this got added into the notes, or some of the stuff got added into the notes, and I didn't know about this. If you ever want to order the levels to match the order of the first appearance in the data, then you can use unique in your levels. Or you could do it after the fact with factor FCT in order. And so this got added into the notes. So if you just want them to be in order based on how the data, how it is within the data or the order within the data that you have, you can either do it in the argument or you can pipe your factor into FCT in order. And as I was reviewing the notes today, I have some idea of where this might be used, but I wanted to ask the group if anybody has like any rationale for why you might want to do this. I have one idea, but I just want to see if the group had any idea of why you might want to do this based on why would you want to order it based on how it showed up in the data? So I don't know. Does anybody have any like feedback for that?
I never had the use case, but you might want to sort your data based on other other columns, other variables, and maybe then the sequence of a factor might be meaningful for whatever reason. That's the only case I could see, but I'm not sure.
Yeah, the only thing I kind of along that lines, like I was thinking like maybe if you had like event-based data, like some type of time series, like you have like the certain ordering of events that happen, and you want to make sure that you capture that order of events in how it shows up within your data, then maybe that's where you would use this. But that was the only like case that I found. I mean, now I got a couple ideas. Or maybe like if you're doing some type of experiment and you have like a repeated measure within an experiment or something like that, and you wanted to make sure that like you have that to go some way. I mean, those are the two things that I can think of, but I've never done this before, so I was just wondering if anybody. Those are my ideas, at least. So, thanks for adding to that, Stefan. I think we were kind of aligned thinking about what that was. Okay, so we can also create a factor when reading in our data. I think this is super useful, especially like I find this useful with like survey data. Like some of the work that I do is we do like an annual survey every year. Usually the levels of the questions don't change, and so it's nice to kind of just like have a CSV or have like an object stored with the different levels within it. And so like when we read in the data, we already have the levels like set aside. And what we can do is on our import read underscore CSV, there is an argument within read CSV called call types or column types. And what we can do is if we wrap it in with this other function called columns, we can say, okay, we have this month column, convert it into a factor, but then use these month levels or set the levels on import. So basically what you're doing is you're just basically taking the factor levels and setting them on the import rather than doing like import your data, then have a separate chunk that's like transform or like mutate your data or whatever it is, or wrangle your data. You can just do it all in one import. And so that's really, really helpful. I've also found this really useful. I don't know how familiar people are with like package development, but like in the package development space, you have your like data raw in your data folder. And so like if you're in your data raw, you'll usually have like an R file that like processes your data. You could just have like an R file that just has this import code into it with your factors stored already. Import that, have that data stored in your package, and then do your analysis with already like the factor level set. And so I've found this to be really useful in that case. It's just like have your factors already set. It's available in the package and run with it. For people that are not familiar with package development, that's okay. Just know that if you decide to go that far, this is a really useful tip for when you're doing like the data raw to data. like setting up your data within your package. So let's talk about the general social survey. I'm not going to dig too much into what the general social survey is, outside that it's just an independent research, or it's a survey done by the University of Chicago or an organization associated with them. It's I think it's a social indicator survey, so there's like demographic information. In this case, there's stuff like survey data related to people's age, race, like demographic stuff, party affiliation, so political party affiliation. So here in the United States, Republican, Democrat, independent, so on and so forth, religion. I have to look up what denomination is, or denom, or yeah, I have to look that up. But TV hours, how many TV hours people spend watching every day or every week. But it's just survey data, and survey data is a place where factors are very useful. So what we can do first, I did want to highlight this, and I don't think this was highlighted in the book. One of the great uses, or one of the reasons why it's good to use a tibble outside of a data frame, is because we get some additional information associated with the different variables that we have within our data. And because factors are a data type that we can use, it's nice because the tibble will indicate for us what variables are actually coded as a factor. So if you look here, you can see marital, which is if somebody's been married, never married, divorced, widowed, it's a factor. Or race is a factor, income is a factor. And so I just wanted to highlight that for people that are new, because it's good when you start doing like data exploration and you're trying to get a sense of your data. Sometimes some data that you get will already have factors coded within it. And so it's really, really good to kind of just double check, okay, are there factors in here? In addition to that, and I actually want to confirm this, I think if you do a glimpse on this, does it give you the factor levels? I'm curious now. I can't remember if it does. I don't know. Let me just dig into this. Maybe I can confirm this later. We can look at it later. I think glimpse might, maybe. Let me see. Glimpse. GSS cat. No, it gives you that, but let's do skim. GSS cat. Sorry, I'm just doing some code down here.
Glimpse,
Go
Glimpse
ahead.
does it, yeah, I think. Yeah, it works for me.
Okay, sweet. So it does show the FCT. I'm just wondering if there was a way to see the levels other than doing levels. Counts, variable, numeric. Oh, well, this is kind of nice. Okay, so I don't know if y'all are familiar with the skimr package, but I use the skimr package for like data exploration. It is phenomenal. I'm gonna pop this up here so people can see it. So here's my code that I have, or this is just RStudio. So here's GSS cat. Here's our confirmation of glimpse. It does show that we have the different factor levels, but I think I've made mention in this group before, but if you haven't used skimr, use it. Skimr is a great package to do like some really quick data exploration. You can just run skim on your GSS cat. But what's really nice is it will show variable type factor, but it will also show you some information related to it. It will also show you how many unique values are within it. So like how many unique values, so unique values within the actual character vector, and then it shows you the top counts, so for each one. So kind of nice. But I don't necessarily think it shows you the levels, so I think you still have to use the levels function to actually see what levels are in the factor. But just quick tip. Okay, cool. Okay, so if we want to get a count for a factor, we just use count. We've seen count before, and here we did this for race, and you can see that the majority of respondents within this specific survey identified as their race being white. And you can see the other breakouts for black and other, so on and so forth. So, but we already talked about count a long time ago, but count works for factor. So we talked about modifying factor order. So what we're going to do here is we're going to just show some different operations that we could do with factors. And one of those might be, how do we actually modify the factor order? And where I see this come up a lot and where the book kind of highlights this is especially with when you're creating data visualizations. This comes up all the time. So the first kind of motivating example to kind of look at this, what we're just going to do is we're going to do we're just going to create some aggregate information, or we're going to create some summary information looking at the average age of respondents and the average number of TV hours that they spend watching. I think it's every week. I'd have to double check that again, but it's just how many hours people spend watching television. I'm not going to go over what this code does, but all we're doing is we're just creating some summary data and we're visualizing it. And so what we're going to do is we're going to put the number of TV hours on the x-axis, and we have this categorical variable for the different religions people identify with, and we can see we just have a basic visualization. Now, from a data visualization perspective, this probably isn't the best way to convey this information, right? If we were looking at a visualization like this, we're more than likely trying to show which people who identify with a specific religion watch the most television, right? Yes, you can kind of get to that answer here. Maybe see don't know, but it really doesn't give us a ranking. So what we can do is we can reorder our factors in a useful way to actually better show the relationship between religion and television watching. And so how we're going to do that is we're going to use this function called FCT reorder from forcats. Some of the punctuation got taken out of this. I'd have to look at this, but when you look at FCT reorder, the functions actually are prefixed with a .f and .x. So when you're looking at these notes, just know that the function names are .f, .x. But what we're going to do is we're going to use FCT reorder first, just to order by the number of TV hours. And so the first example being here, we're just going to take the religion and the religion variable. Well, we're going to mutate it. We're going to take the religion variable and we're going to reorder that factor by the number of TV hours. So the category within our factor that watches the most TV hours will go first, second, and then third. And what that's going to do is it's just going to order our visualization to show you which category within our factor of religion watches the most television. Again, if you take some time to kind of review this, you're going to notice that this really isn't, well, I shouldn't say it's not useful, but one thing that we may not be, maybe this one category don't know is not what we're really concerned about. Maybe we want to focus on a very specific set of religions. Maybe we want to move this down below it, so on and so forth. Other maybe be something that we can move, but we can just have other functions that are available to us to kind of change these however we want using some forcats function. But getting closer helps us a little bit by just moving the factors around, and it's just a really simple FCT reorder. The last thing that I wanted to highlight with this is the book talks about, the first example is actually putting FCT reorder in your ggplot2 code, but it does make the suggestion that maybe you should do mutate rather than doing it there. I've done it both ways. I understand the argument to do a separate mutate because it's very clear that you're doing some data wrangling beforehand, but if I'm doing something real quick, I might just put the FCT reorder in my ggplot2 code. I think it's differences in how people want to work and how explicit you want to be. Choose your own adventure, I guess. Okay, so let's talk about changing the levels of the factor. Again, we're going to just do some summary information here. We're just going to get some mean age, mean TV hours, but we're going to do it by income. We're going to group by income and then summarize age and then TV hours group by income. And say we do this, and part of this factor within income is not applicable, okay? So what we can do is if we want a specific level or set of levels to be near the end or at the bottom, we can set those levels here after with using FCT relevel, passing in our income, and then putting n applicable at the end. So basically what's going to happen is we will maintain our factor order. So 1,000, 1,299, so on and so forth. But it will take that not applicable level and move it all the way down to the bottom. And I see, Stefan, you're kind of trying to see it here, so let me bump it up for you. So what all this did is it kept the ordering of our income, and then it just took not applicable and moved it all the way down to the bottom. I have done this. Oh, go ahead, Stefan.
Yeah, I wanted to. So I think effectively, doesn't it become the first level? Because doesn't ggplot start with the first level from bottom up?
Ooh, that's a great question. I am not sure. That's a great question.
But maybe I misremember.
Let's see. Is there a way that I can confirm that? I'm sure you're right. Let me just double check. How can we confirm that? So FCT reorder. So that's the previous one that we did. So let's see, FCT reorder. Okay, so that's religion. This is okay. So this is the one that we're looking at. Oh, that's weird. Oh, that's by age. Am I looking at the right one? Why did we do this? What am I looking at? Sorry. No, no, no. We're looking at not applicable.
Yeah, so I think the default value, if I look at the factor level definition, it says after the default value is an integer of 0. And so that would put it in the first position, right?
Oh, okay, that makes sense. So let's see. So let's do FCT relevel because we can look at this here. So then if we do this and then we do our income summary, and then if we do, is it our income? And then not applicable. Let's see if this works. No. Well, not applicable, right? Applicable. Oh, I know what I did. Duh. So I'm doing this. Try this. Okay, so you are right. Yep, it does do that.
No.
Because here's the levels, right?
Oh, yeah. It makes it the
Then
first level. Yeah.
it does. Yeah, you're right. Yeah, it does. Absolutely. Yeah, you're right. So it does. It does move it the first one. What is the ordering? What is the ordering without doing the relevel? So our income summary by our income. Okay, so the ordering before we do the FCT level is no answer, don't know, refused. Then it does the levels for income. No, it does the high levels, and then not applicable is at the end. So basically, yes, it is taking it from the end and moving it to the front. Yeah, excellent. Cool. I did not know that. Okay.
I think the main takeaway is like when you want it on your ggplot, whatever the ordering is, if it's from top to bottom, then you have to basically think in reverse, just so you know. Like I think I encountered this before for my work.
I sometimes I hate to say this. Sometimes it's like sometimes you try something and see if it works, and then if it doesn't, then you try something else. Like
Yeah.
if not applicable is at the top, it's at the bottom. But no, it's good to know that because I like you said, the main takeaway is like knowing what is your factor levels, like what is your factor levels at the start, and then knowing where it's going to be put positionally because you could, there might be a case where you want a specific value like in the middle somewhere, and so you would have to figure out like which like forecast functions you want to do that. Yeah, cool. That's awesome. I didn't know that. Thanks for sharing. Okay, so let's bring this back over here. Okay. Yeah, I've done this all the time though, like with survey data, like because you obviously want to be clear that like there's no responses. You want to include those all the time because if there's high no response there, that could indicate something in the work that we do. And so I do this all the time of like, yeah, you have all the survey responses, but you have like no response all the way at the end. So you're still being transparent that there were no responses within your data. Okay. Let me kind of zoom out here real quick. Oh, don't give me the spinning wheel of death. Okay. Okay. So that's that one. Okay, so this one took me a second to recognize what was going on here. Again, what we're doing here is we're just doing again some calculating a proportion, and we're calculating a proportion based on age and marital status. So here's just some kind of like summary code or some code to kind of create some summary values and calculate a proportion. And what we're basically doing is we're showing marital status over different age, over the age of respondents. So when you first do this, you'll notice over here on the legend, this doesn't really match up with how they are ordered within it. So, no answer would be at the bottom. But if you look at never married would be probably like the fourth level, but not necessarily the second. Separated would be maybe the fourth or fifth, and so on and so forth. So what we can do is we can use FCT reorder 2, and we can order it by age and proportion. And what happens is it's the same graphic, but what it does is it changes the colors and matches them up with what's over here on the right. So it makes it look a little easier to read. So here we have widowed, which is red, married, which is yellow, divorced, never married, no answer would be at the bottom, and then separated. And so this, from what I kind of understood this does, is it doesn't change necessarily the data. It only changes the representation of the colors and the actual legend to make it easier to read. That was my takeaway. I don't know if anybody had any other takeaway, but it took me a second to really kind of understand what was going on here. But I don't know. Does anybody else have anything that they took away from the specific example? Yeah, it was a really subtle difference that I couldn't really pick up right away. But then I was like looking at it, I was like, oh, I see why you might do this, because it's just making it easier to read the plot. It's modifying the levels here in the legend so it's easier to read the actual plot. Okay, changing the order of a bar plot. Okay, so what you can do is there is a function called factor infrequent. So if you have a specific, if you want to like order from like least to largest, what you can do is you can use factor infrequent, and then it will organize it from least to largest. And so we're using GSCat again. We're going to mutate this marital variable here. And what we're going to do is we're going to change this factor. We're going to order it by what is the most infrequent, or which category has the least within it. We're going to reverse that, and then we're going to create a bar plot to order the bars for us. And so in this specific data set, respondents who didn't answer were the least, separated was the second least, widowed, so on and so forth, divorced, never married, and married. And so we can use the factor and factor infrequent to identify or order based on which value is the most least infrequent, and then reverse just reverses it. So if we didn't have reverse here in this like chain, what we could do is we could move married to the first. So pretty straightforward. I did like this right here because I have started to do this quite frequently in my own code. I know there are some people out there that are not a fan of doing this, but having a pipe within a pipe. So what you can do is you could like nest like a pipe like statement inside of your mutate outside of like the broader set of pipes you can do. I've started to do this. Sometimes I've started to do this in my ggplot2 code. But it's just really kind of interesting to see that you can do this again and mutate. So it's not explicitly talked about in the book, but I just thought it was interesting to highlight like that again, that you could do that. Okay, this is probably the biggest takeaway from the book for me that I'm going to take away from this section is modifying factor levels. I will tell you that in the past, it's kind of an anti-pattern to do this. It works. Is I would previously like do a case when, change it, and then turn it into a factor. It works, but what you can do is, and more conveniently, you can use a function called factor recode, so you don't have to do necessarily like the case when, then create a factor. You can just do it right away, right? So what we're going to do here is with this variable called party ID in the data set, here are the actual labels that are there. Okay, and maybe these aren't necessarily human readable. You could make the argument, yeah, that maybe they are, but maybe you want to make them more clear. So what you can do is here in your mutate, you can mutate party ID and factor recode it, and then write this kind of statement here where you could just basically be like Republican strong will equal what the previous thing is. So the way I read this is what's the new label? What's the old label? So this will be the label that it will get once you change it. And so you can kind of see what's going to happen here when we count it. It's going to change it into these new labels. Automatically going to take this away. From this was probably the biggest takeaway, and I have some code that I'm going to go fix, not necessarily after this, but when I come across it, then I'm going to implement this because this just makes more sense. It's easier to read than like a big case when statement where it's like case when this equals this tilde whatever. So this is more clear. The only thing that I don't like about this that I think, and I don't know, we can talk more about it, is there a way with FCT recode to take this data set and make it like separate, like as a separate object somewhere else? So my thinking is that I thought the design of FCT recode for these recodes would be within a character vector or a list or something like that, so that you could take that out and you would have a separate object. So I don't know if you could do that. But when I first looked at this, I was like, oh, well, but what if I want to take these levels out and I want to put them somewhere else so that I can, do whatever I want with them without actually having it within the actual FCT recode. I don't know if anybody's familiar with that, but that was like the first thing. I was like, where I might not use this, but yeah. So bye bye
I
case
think you
one.
can, is what I
Can you?
see. It says a sequence of named character vectors are the dots. So you could define this also as a single character vector, right? Just put a C around it and then have a named character vector, and then that would work. And you can save it
Yeah,
that way.
that's nice because this is like the one thing that I think about sometimes. So like with survey data that we get sometimes, they're surveys that are fielded by other people or like other organizations, and as much as I would like them to maintain their factor or their question levels or their scales to be consistent from year to year, they're not always. And so sometimes we have like a 2020 level, a 2024 level, and so it would be nice to have like a separate set of levels stored somewhere else to be like, oh, if this is the 2024 survey, here are the levels for this. If this is the 2022 survey, or whatever. So yeah, but that's great to know. So thanks for looking into that, Stefan, because I think that's important, especially within survey data, because scale levels get changed all the time, and that is the bane of my existence. Okay. Also, what's nice is we can use this FCT recode to like put things together. So same kind of structure here. I'm not going to talk too much about the syntax, but say we want to kind of group things into a similar category, we can do that here. So if we wanted to put no answer, don't know, and other party into other, we just have to do it this way. Real simple, real easy. And then here's just to kind of confirm what happens when you actually do that. The book does push a warning to say, hey, you have to be aware of which groups you're putting in, because R is not going to tell you if your grouping is correct. So it's on you to make sure that you validate, like, are my groups correct and are they correctly labeled? So that's just an important point if you do decide to use FCT recode to group things into a similar category. And then we have another way to do this. We can collapse levels into one. I thought this was another thing that I'm going to take away as well. So say we don't like any of the labels and we want to simplify this even further. Well, there's this function called FCT collapse, which is a variant of FCT recode. So say we just wanted some really simple labeling like DEM, independent, Republican, other, and we had different sets within it. We can do that with collapse by saying, here's the label we want, and here's the character vector of all the different factor levels that we want to be associated with other. Here's the count to confirm what happens when we do that. Again, you're responsible for understanding how this grouping is actually being set. So if you accidentally miss, if you have strong Republican within Democrat, there you go. But that's on you to kind of know that. But again, this is probably one of the other things I'm going to take away from this kind of chapter. And I see Stephanie add something when passing a name vector. Oh, so you have to use a three. Is that a three bang? I can't remember what they
Yeah.
call that.
I just saw it. I was wrong, so I just wanted to put in the correction.
Oh, okay, cool. Yeah.
But you still can use a name character vector. You just have to do the triple bang. Yeah.
Is that what it's called, the triple bang? I can't remember.
I don't know.
I know the two is a bang bang, right? All right, well, if that's a new thing and nobody's named it yet, we've just coined it. So people later on in the world will be like, this group came up with the name of it. I'm going to call it triple bang. I don't know. Let's see. Okay, so lump. Lump is great. I've used lump. I need to use lump more often, but it's really cool. That's a really like nice convenience function to help you quickly like lump things together. Um, so like if you want to lump together small groups to make a simpler table. So like a great example of where FCT lump comes in is like, say you have a factor with so many levels and you know that you can't display all those levels in a table. You know that you can't display them in like a visualization, but you just want to like, maybe show the top 5 and then put everything else in an other. So rather than going through and like collapsing them or combining them, you can use these FCT lump or this family of FCT lump functions to just have it make the calculation for you. And so one of them is low frequency. And so what you can do is you can use FCT lump on your factor variable, and it will just create groups based on low frequency. So it will take all low frequency groups and put them into one. And so it doesn't really work in this case because in our data set, the majority of respondents identified as being Protestant or following Protestant religion. So there's not a lot of differences in here. But what's nice is it will take this, and if there was other levels that were close, it would have them here. But then it lumps all the low frequency religions into its own like other, and you don't have to specify those on your own. It just does it based on the actual data itself. I do highly suggest, and I have these here. I do highly suggest looking at FCT lump min and FCT lump prop because, oh, yeah. Well, let's talk about these here. So min and prop, what you can do is you can set like a certain like kind of floor to say like these values have to show up this minimum of times before it gets its own category. Prop is just looking at the proportion. So it has to reach a certain proportion within it before it actually shows up. And then what's nice about FCT lump is it also gives you an N argument to say like, I only want like the top 5, the top 10, whatever it may be. And so you can specify that. I think the examples are really good here to kind of show you how these work. So here's FCT lump N. So basically we would have this factor here. So X is the factor. I guess I could show you this real quick. Here's the factor, creates it. It's creating letters, doing some stuff to kind of create some example data here, and you can kind of see the distribution of how they show up. FCTN, sorry, I realized that this is really small. FCTN, we could take that factor X. We can say, hey, if it doesn't show up at least 3 times within our data set, just give it an other. Okay. And if we wanted to, there's another argument here where you could specify what this is. It just defaults to other, but you could specify it to whatever you want. If you want to base it not on an actual like value cutoff, you could do it by proportion. So if you want to say like, if it doesn't show up at least 10% of the time, 0.01, use at FCT lump prop 10%. And so the values that don't show up at least 10% of the time would be labeled other. Yeah, so, and then min, I can't remember where min is. Min, so basically it would be like, it has to at least show up a minimum of 10 times, I think. So if it doesn't show up a minimum of 10 times, then it just gets dumped into an other bucket, right? Or no, I think I said N wrong. Did I say N wrong? I think I said N wrong. I think FCT N lump N is, I just want 3 categories. What are the top 3 categories? And then FCT lump min is actually like a floor that the number of values within the factor has to show up to at least 10 times before it gets its own category. Otherwise, lump it into another. So I said that wrong. I apologize. FCT lump n is, I want the top 5. If I want a cutoff using like a minimum value, use FCT lump min. Cool. Does anybody want to add anything about lump? I think this is the, again, props to the naming team, whoever did this, FCT lump. Good function name. Love it. So props to whoever named that set of functions. Okay. Ordered factors, so that we're getting towards the end here. So if you have like ordinal level data where you have a categorical variable that has to take a very specific level, so like, like a scale item, like strongly agree, can't think today, disagree, strongly disagree. This is where ordered might come up. Because that it has to take a very specific, am I saying that right? Apply strict ordering and equal distance between levels. I don't know if that's a good example of the scale items, because you could use factor. I don't know. Does anybody have any examples of where they've used ordered before? Because I don't really use it. We'll have to have a strict thing, but I don't know. I don't know if anybody has any like examples of where they've used ordered. Yeah, it got a little confusing because it like went into some like really heavy. I kind of understood the reason for like ggplot2 code and like the scale color like that it uses in this case. But when it got started talking about like polygonal contrasts, like I haven't done contrast. I haven't done like any like modeling with contrast, if this is what it is, for a long time. So it was really kind of hitting a memory or a set of knowledge that I haven't accessed in a very long time. So I don't know if anybody has any like comments about this, please let me know, because I didn't really fully understand where you would use the ordered factors. All right, cool. Well, if anybody in the future comes across this, please let me know where you might use it. Obviously, there are some very specific warnings and things that you need to know about. So, all right, I said we were gonna get through this a lot faster, but I obviously talked a long time because I find factors to be interesting and useful. But with the 4 minutes that we have, does anybody else have any other things that they want to share? Any other comments or anything else? All right, cool. Well, I really appreciate everybody joining in. We'll pick up with chapter 17 next time, which is going to be dates and times. And I'll